Hi everyone. In this presentation, I will give you a brief introduction of our tool called BigTest that automatically generates test suite for data flow programs. Big data applications are prevalent in almost every production software today. They process large-scale data to extract valuable insights. While testing for traditional softwares have matured over the past 2 decades, testing for data flow programs is still in its adolescence. And the reason behind this is that these programs have relational skeleton, which is backed by hundreds and thousands of lines of code. They also have complex user-defined functions, which contain complex string operations, as well as unbounded collections, which are really hard to model symbolically. So the question is then, how do we test these applications effectively and efficiently? So what are we doing today in terms of testing these programs? Normally, we download a small sample data on our local machine and then test the program on that small sample. However, using a small sample means that we cannot exercise all the paths in the program. And if we increase the size of sample, that kind of defeats the purpose of sampling in the first place. On the other hand, traditional software has tools for automated test generation which are very effective and are based on techniques such as symbolic execution. However, in big data applications, each data flow operator is backed by several hundreds or thousands of lines of code, which is not feasible to model through symbolic execution. So to overcome the limitations of both of these approaches, we designed BigTest. BigTest takes in a big data application as input and it generates a suite of test data that provides really high test quality. Internally, BigTest splits the data flow program into a list of user-defined functions and a list of data flow operators. For user-defined functions, it performs symbolic execution on those functions. For data flow operators, it models the semantics of the implementation of data flow operators in first-order logic, and then use it in tandem with the symbolic representation of user-defined function to represent the entire program in a symbolic form. Once we have that symbolic representation, we give it to a CVC4 theorem solver or Z3 theorem solver and generate test suite that provides really high test quality. Let's see BigTest in action on a sample program. Here we have the source code of the application that I have shown you in the slides. Once we run BigTest, you can see the progress of BigTest in the console log window, as well as the progress of symbolic execution on each user-defined function. And here you can see all the path constraints and the corresponding data generated by the theorem solvers. Finally, each of these test data can be used as input to the test function for this program.